Welcome to the DIY Honda Garage channel. DTC P0141 refers to a malfunction in the heater circuit of the secondary heated oxygen sensor, HO2S, specifically sensor 2. This issue impacts the vehicle's exhaust system, where proper emissions readings are essential for optimal performance and compliance with environmental standards. The secondary HO2S, sensor 2, is located downstream of the catalytic converter and is critical for measuring oxygen levels in the exhaust gases. It helps the engine control module, ECM, to adjust fuel mixture and optimize combustion efficiency. When this sensor's heater circuit fails, it can lead to increased emissions and reduced engine performance. In the case of a malfunction, the powertrain control module, PCM, will trigger the DTC, leading to potential warnings and performance issues in the vehicle. The error description for DTC P0141 indicates a malfunction in the secondary HO2S sensor 2 heater circuit. This sensor's primary responsibility is to monitor the level of oxygen in the exhaust gases after the catalytic converter. It aids the PCM in managing the engine's air-fuel ratio, ensuring optimal combustion. The heater circuit allows the sensor to reach operating temperature quickly, thereby improving its response time and accuracy in reading exhaust gases. Located downstream from the catalytic converter, sensor 2 plays a pivotal role in emissions control and overall vehicle efficiency. A failure in this heater circuit can prevent the sensor from functioning correctly, prompting the PCM to trigger the DTC and potentially illuminating the check engine light. Several possible causes could lead to the triggering of DTC P0141. A short circuit in the wiring can disrupt the electrical flow to the secondary HO2S, sensor 2, resulting in a failure of the heater circuit. Additionally, the sensor itself might be faulty and incapable of operating correctly, leading to incorrect readings or complete failure. Open circuit issues can also occur when there are breaks or damage in the wire, preventing proper connectivity between the sensor and the control module. Each of these causes can be investigated in the troubleshooting steps to determine the exact source of the fault. Properly identifying these issues is crucial for effective repairs and ensuring the vehicle meets performance and emission standards. Vehicles with DTC P0141 often exhibit certain symptoms that can lead to driver inconvenience. The most prominent sign is the illumination of the check engine light, which serves as an alert of potential issues within the engine system. Poor fuel efficiency may also be observed due to improper air-fuel mixture caused by the malfunctioning sensor. Furthermore, an increase in emissions may result in the vehicle failing state emissions tests, leading to further complications. Drivers may notice reduced engine performance or responsiveness as well, due to the PCM's inability to adjust the engine parameters accurately. Recognizing these symptoms early can help prevent more severe issues down the road. For the first troubleshooting step for DTC P0141, begin by turning the vehicle's ignition to the on mode without starting the engine. This allows the onboard systems to initialize. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs. This action resets the system, allowing for a fresh assessment. After clearing the codes, start the engine and let it idle to observe any changes. With the engine running, check for any pending or confirmed DTCs again via the HDS. It is crucial to determine whether key 0141 is indicated. If yes, this confirms that the failure has been duplicated and you can proceed to the next step. If it's not indicated, this may suggest an intermittent failure, and further investigation into the wiring or connections should be conducted. To proceed to the second troubleshooting step, turn the vehicle's ignition to the off lock mode. This is essential for safely handling electrical components. Next, locate and check fuse number C30, a 10A fuse located in the under-dash fuse relay box. This fuse is key to the power supply for the oxygen sensor heater circuit. If the fuse is intact, it indicates that the IG1 ACG IG1 SO2 wire is not shorted, allowing you to continue to the next step. However, if the fuse is blown, a short in the IG1 ACG IG1 SO2 wire must be repaired, after which the fuse should be replaced to restore proper circuit functionality. In this third troubleshooting step, the first action is to disconnect the 4P connector from the secondary HO2S sensor 2. This disconnection is necessary to safely test the internal resistance of the sensor's heater circuit. Once disconnected, measure the resistance across test points 1 and 2, specifically the terminals at the sensor side. It's important to perform this test while the vehicle is in the off-lock mode to ensure safety. At room temperature, the measured resistance should fall between 5.4 and 7.3 ohms. If the resistance falls within this range, thus confirming the integrity of the heater circuit, you proceed to the next step. Conversely, if the resistance is outside this range, it suggests that the secondary HO2S sensor 2 is faulty and must be replaced. The fourth troubleshooting step involves checking for continuity in the heater circuit of the secondary HO2S sensor 2. With the sensor's 4P connector still disconnected, continuity can be tested between test points 1 and 2. This test should be performed with the vehicle turned off, lock, to ensure no power is flowing through the system. If continuity is detected, this indicates that the internal circuit of the sensor is intact. And the next step needs to be followed. If there is no continuity, it suggests the internal circuit of the secondary HO2S sensor 2 is compromised. In this case, the faulty sensor should be replaced to restore proper functionality and reset the DTC. Proceeding to the fifth troubleshooting step, the first task is to jump the SCS service check socket line using the HDS. This action disables certain vehicle functions to facilitate the testing procedure. Following that, disconnect the PCM connector C, which is a critical component of the vehicle's engine management system. Once the PCM is disconnected, check for continuity between test points 1 and 2 in the SO2HT line. This will involve verifying continuity from terminal number 9 of the PCM connector to body ground. If continuity exists, it indicates that the wiring is intact, but may require further investigation for potential issues. If continuity is not found, the SO2HT wire is likely shorted, necessitating repairs between the PCM and the secondary HO2S sensor 2. In the sixth step of troubleshooting, you will be checking the continuity within the SO2HT line. With the vehicle in the off-lock mode and the relevant connectors disconnected, measure continuity between test points 1 and 2. Test point 1 corresponds to the number 3 terminal of the secondary HO2S sensor 2 4P connector, while test point 2 corresponds to terminal number 9 of the PCM connector C. If continuity is found, it indicates that the circuit is intact and functioning properly, allowing you to proceed to the next troubleshooting step. If no continuity is detected, this signals an open circuit within the SO2HT wire that requires immediate repair between the PCM and the secondary HO2S sensor 2 to restore proper function. For the seventh troubleshooting step, switch the vehicle ignition to the on mode without starting the engine. This action enables you to measure the voltage at the secondary HO2S sensor 2 4P connector while it remains disconnected. Specifically, you will measure the voltage between the number 4 terminal of the 4P connector and body ground. If battery voltage is present, It indicates that the IG1-ACG, IG1-SO2 line is functional, and there is no open circuit. Should this occur, ensure that the PCM is equipped with the latest software update. If not, perform the update. If the issue is resolved after updating the PCM, the troubleshooting is complete. If replacing the PCM resolves DTC P0141, then the original PCM should be replaced. If no voltage is detected, an open circuit exists that must be repaired in the IG1-ACG, IG1-SO2 wire between the secondary HO2S sensor 2 and the number C30-10A fuse. After completing all the necessary repairs for DTC P0141, the final verification step is crucial to ensure that the issue has been resolved. Begin by rechecking the DTC using the Honda Diagnostic System, HDS. This step allows you to confirm that no further DTCs are indicated following the repairs. If the P0141 code is no longer present, it indicates that the heater circuit malfunction has been successfully addressed. Next, conduct a test drive of the vehicle under various conditions to validate the repairs made. Monitoring engine performance and emissions during the test drive is essential to ascertain that everything is functioning correctly. Only after these verifications should the vehicle be considered fully repaired, ensuring the integrity of the exhaust monitoring system. Preventive maintenance is essential in ensuring the longevity and reliable performance of the secondary HO2S sensor 2 and its associated components. Regularly inspecting wiring for signs of wear, abrasion, or corrosion can prevent short circuits and other electrical malfunctions. Keeping connectors clean and properly seated ensures consistent electrical contact, which is crucial for sensor performance. Another valuable preventive measure is to routinely check and update the PCM software to ensure optimal sensor calibration and performance. By following these practices, vehicle owners can mitigate the risk of DTC P0141 and maintain the efficiency of their Honda Fit. Proactive maintenance ultimately leads to reduced repairs and better vehicle lifespan. In conclusion, DTC P0141 signals an issue with the heater circuit of the secondary HO2S sensor 2, which significantly affects vehicle performance and emissions control. Understanding the function of this heater circuit is essential for effective troubleshooting and repairs. The systematic approach outlined in the troubleshooting steps allows technicians and vehicle owners to accurately diagnose the issue and implement necessary repairs. Post-repair verification ensures that the problem is resolved completely. Additionally, routine preventive maintenance aids in avoiding such issues in the future, further enhancing vehicle reliability. By adhering to this guidance, Honda Fit owners can ensure their vehicle operates efficiently and responsibly, maintaining both performance and compliance with emissions regulations. Please like and subscribe to the channel. See you next time.